Okay, let's say we have a substance here and it takes up about this much space. Okay, and then let's say this substance is gold. So we have a certain amount of gold, takes up a certain amount of space. It also weighs a certain amount of, let's put this on a scale. It weighs a certain amount of grams or ounces, however you want to weigh it. But when this same substance, and you don't add or subtract any to it, but when it's heated up, so heat energy is added, then this will be larger in size. Now I'm gonna, go overboard. It's probably not going to be this much larger, but it's going to be larger in size, but it's going to weigh the same amount. That's because the molecules spread out when a substance is heated, right? It becomes less dense. So when molecules spread out when a substance is heated, it equals less density. That's just what's going on. So this gold might measure a larger circumference, a larger cubic, call that, like cubic meters or cubic centimeters. It may measure larger that way, but its mass will remain the same. And okay, so you need to remember that density equals mass over volume. I think you could do this. You draw this like a heart and go like that. That's how you remember that it's mass over volume. So if you're hit with a question to calculate something's density, remember that the mass is usually going to be measured in, like I said, cubic meters or cubic. Oh, I got that wrong. Sorry. Mass is usually going to be measured in grams or milligrams or ounces. And then the volume, circumference, right, is going to be measured in the cubic meters or cubic centimeters. And those are written like this: meters cubed or cm cubed. So don't be afraid of those numbers when it has like 3 cm3. That's just referring to the volume. So you know that number goes on the bottom of your equation. And then if it's followed by grams, milligrams, or ounces, something like that, then that number goes on the top. So then you can take those numbers and calculate the density.